Hello, everyone. This is Professor DePaulo. Welcome you back to Abnormal Psychology. And in this chapter, we're going to be talking about research and research methods within abnormal psychology. So, clinical researchers look for a nomothetic understanding, which is the general or universal laws of truth. They're not as interested in studying what works for one particular individual, but basically for the entire population. And this is important because something as common as, say, depression or anxiety, there's a large population of individuals in the world that have these conditions that tend to be comorbid. They tend to occur together. And there's no one particular trigger or one particular gene that's leading to these disorders. It's a combination of factors, and everybody's different. So you want to kind of average across all those differences and come up with, in general, this is basically what happens in the population of people that have anxiety or depression. This may not be as important for treating one particular individual, like a particular client that you're working with, but it generally holds to the entire population as much as possible. Now, the case study does relate to one particular individual, and it is very common within clinical psychology. It is also problematic because the case study is this intensive analysis of a single individual. And for a really rare phenomenon like progeria, the tragic condition that leads to rapid old age in young children and eventually their death at around 14 or 15, the case study would be great to study a condition like progeria because progeria is very, very rare. And you're not going to be able to gather a significant sample of people with progeria. But if you're studying a more common malady like depression, and I always bring up depression because it's probably the most common, depression and anxiety, a case study is not going to tell you much about depression in the general population. It's going to talk about depression in the one person you're studying, which can be helpful if you're treating that person. But if you want to know about depression, studying one person is not the answer, because depression has many different symptoms. So the benefits of the case study are mainly for drawing conclusions about rare phenomenon, where you're not going to get a large sample of people to study. The pitfalls are that you can't generalize to the population by studying one individual. So the limitations of the case study include low internal validity, which means you cannot draw cause and effect conclusions based on the case study. Obviously, you're not controlling any of the variables. You're just basically going by what one person is telling you. You know, I had a rough childhood, or I had some traumatic event in my life, and that led to the triggering of this disorder. That doesn't give you cause and effect conclusions. The only way you can have cause and effect conclusions is by running a true experiment. And the case study is definitely not that. There's no manipulation of the independent variable here. So it has low internal validity, which is basically the ability to draw cause and effect conclusions. It also has low external validity, which is the ability to generalize from a sample to a population. And the reason that the case study has low external validity is everybody's different. And it's going to be really hard to generalize from one person to a population of many, many people. That symptoms are different, though the triggers of the illness are different. The treatment for the illness is different. You know, this would only work in the case of a very rare disease or disorder where there's not much to study, and therefore the case study is ideal. But in the terms of something that's more widespread, you want to always get a sample, and you want that sample to be as large as you can possibly afford to get, or logistics dictate. So the case study is not ideal, even though it's used all the time in a clinical setting. Now, what the caveat is, if you're just looking to help your client or your patient, depending on where you're located in a hospital versus an outpatient facility. If you're looking to help your client or patient, then looking at a case study of their life and trying to develop a treatment tailored to them is ideal. But researchers are generally not looking just to help one person. They're looking for general answers, nomothetic understanding. And the case study is not going to give you that. So an alternative to the case study is the correlational method, which involves survey research. So you look at a bunch of variables that might lead to a particular disorder or that are associated with a particular disorder. And then you collect a sample of individuals from the population that have that particular illness, and you study them and you ask them a bunch of questions on the survey, and based on their responses, you determine which variables or which questions that you ask them are predictive of the particular disorder you're studying. So if I'm studying anxiety, let's say I'm studying generalized anxiety, I might ask about sleeping habits. I might ask about stress levels at work, relationship issues. I may ask about sleep. I may ask about eating patterns. I may ask about socioeconomic status, how much money you have. All those factors could play a role in predicting an anxiety disorder. And based on this correlational method, I send out a survey with a bunch of questions on it. And based on the responses, I can then measure these variables that I just mentioned and see if they predict anxiety. And with a large enough sample, which I would suggest being over 100, and greater if you get the biggest sample you can reasonably get. It's a little easier to get the sample online, but you have to still pay people. So how big your sample is going to be depends on how much money you have to spend, how much time you have to collect data, how you're collecting the data. All of that's going to play a role in what kind of sampling you're going to get. But I would be satisfied with a sample around 100 in a survey, at least 100, probably more. And based on the responses to the survey, you can then analyze, is there a relationship? Can you predict anxiety based on these other variables? And so you could build a model, a regression model to predict anxiety. Or you could just look at correlation. Correlation is just these variables go together. Regression is more that this variable happens first and then I predict something in the future. And that gives you information. It doesn't give you causality. It doesn't give you cause and effect. Neither does the case study. But it gives you more than the case study because now you're looking at a sample. And you're able to measure different characteristics or different variables for the sample of people, whereas the case study, you're not able to really do that. I mean, you're not doing a survey in a case study. You're using mainly interviews. And you're quantifying one person's experience versus a whole sample of people. So even if your sample is 100 people is better than one in terms of the confidence you have in drawing a conclusion. So it has higher, what we call external validity. It's easier to generalize the results from a sample to a population, much easier than to generalize the results from one person to an entire population. So correlational data can be graphed, and the best fitting line or regression line can be drawn. And you have positive correlations, negative correlations, and zero correlations. We're not really interested in zero correlations because that's not telling us anything. We're looking for either a positive or a negative correlation. Here's an example of a positive correlation. You see that the dots in this scatter plot, so each person gets a dot based on their scores on these two variables. The x-axis is stress and the y-axis is depression. So is there a relationship between stress and depression? Each person gets a dot depending on their two scores of stress and depression combined. And then we draw a best fitting line, which is called the regression line. And we see if the regression line is very close to the dots. The closer the dots are to the regression line, the stronger the relationship, the higher the magnitude of the correlation. And if this regression line has a positive slope, which it does here, we say the relationship is a positive correlation. As stress increases, depression increases. As stress decreases, depression decreases. So if the two variables are going in the same direction, it's a positive correlation. And here they're going in the same direction. You see that upward slope from left to right. And it looks pretty strong because those dots are close to the line. They're not exactly on the line, but they're close. Now, if all those dots were exactly on the line, then you would have a perfect positive correlation. It'd be 1. That's not realistic. You're not going to have a situation where all your data points are exactly on the regression line. It's not, that's something out of a stats textbook. That's not something that you see in real life. But this is really strong correlation because the dots are very close and a couple of them are on the line. So this is a very, very strong positive correlation. And that makes sense. You're under a lot of stress, you're going to be depressed. That sounds like a very strong relationship there. The negative correlation is going in the opposite direction. So it's going down from left to right. So as the one variable increases, the second variable decreases. They go in opposite directions. So in this particular situation, as activity scores increase, depression decreases. And you see the slope of the best fitting line, the regression line, is negative. Most of the dots, once again, lie close to the line, which means you have a pretty strong negative correlation here. As activity goes up, depression goes down. That makes perfect sense. If you're exercising and you're moving around, your depression is going to go down. And the reason why that's the case is it's believed due to the role of serotonin. That movement increases serotonin in the brain, and increasing serotonin in the brain decreases depression levels. That's the idea. And so exercise and just being active, going out, social could be also be socializing. Activity level is not just, exercise. It's, are you going out? Are you doing things in your life? And so if you're doing things in your life, you're also meeting people and enjoying things and having fun, et cetera, et cetera. So that only makes sense that if you're doing that more, you're not going to be depressed. If it includes movement and exercise, then of course, if you exercise more, you're not going to be depressed as well. Exercise is very important for depression, to keep depression in check. And here's the no correlation. This is IQ and depression score. There's no relationship here. That's not surprising. Depression is an equal opportunity illness. And so you see the points, the dots here are relatively equally scattered throughout around this line. And the slope of the regression line here is 0. And that basically means there's a 0 correlation. It's a horizontal line, the slope is 0. Now the magnitude of the correlation is the strength of the correlation. The closer the dots are to the line, the stronger the correlation. In this example, the correlation is weaker than in the previous slide because the dots are further from the regression line. They're spread out more. They're not clustered tightly around the line, so the magnitude of this correlation has decreased in this example. The closer those dots are closer together around the line, the stronger the magnitude of the correlation. Now, the magnitude of the correlation ranges between -1 and +1. So you can't get outside of -1 and +1. The closer your value of the correlation is to -1 or +1, the stronger the magnitude of the correlation. Basically, the stronger the correlation is. So if you have a strong correlation, the dots are going to cluster together around that line. And a weaker correlation or a weaker magnitude, the dots are going to be spread out more. but you can't get anything higher than +1, and you can't get anything lower than -1. The range is between -1 and +1 inclusive. And the value we give to the magnitude is called the correlation coefficient. Technically, it's the Pearson product moment correlation coefficient, because there's many different types of correlation coefficients. But for this class, we're just going to be talking about R, little r, the Pearson R, you might hear it referred to. It's a measure of linear association. So basically, that means it's a measure of how well you can fit a straight line to the data. And it's useful to use a straight line because a straight line is very easy to explain. The straight line may not be the best fit for the data. Maybe the best fit for the data is a polynomial, like a cubic, where you have multiple peaks and valleys, or a quartic or a quintic equation. That might fit the data the best, except you can't explain that. You can't really explain anything more than, I would have difficulty explaining anything more than a parabola, a quadratic, equation to fit the data. And even in that, the quadratic, it can be tricky. It doesn't occur very often. The straight line is definitely preferred. Even if it's not the best curve to fit the data, it's the easiest to explain. And that's why in psychology we use Pearson R, because it's the measure of linear association. It's how well the straight line fits the data. And straight lines are easy to explain, and therefore we want to use them. I've had situations where I'm looking at things and I said, oh, that's a great fit for the data. And they look at the curve and I'm like, how am I going to explain this? The answer is I can't. But with a straight line, very easy to explain. You want correlations closer to -1 and +1, even though you're not going to get that in real life. You're not going to get +1 or -1. But if you get something large, in psychology, if I get 0.5 and 0.6, I'm happy. That's a pretty good correlation in psychology. In physics, it's not so good. In biology, it's so-so. Right? In chemistry, it's not so good. The reason being in physics and chemistry is we're measuring without error. We're pretty clear on what we're trying to study and how we're trying to measure it. So if you're measuring weight, we know how to put people on a scale. We know how to put things on a scale. We know how to weigh chemical compounds. We don't debate that. We don't say that your scale is better than my scale. No, it's a scale. It's calibrated. It should be basically the same. But in psychology, if I'm measuring depression, the way you measure depression may be different than the way I measure depression. And we may disagree. And who's right? I don't know. That's debatable. I mean, can you replicate either particular method of measurement? It's possible, probably not, because we have trouble replicating. Replicating basically means running the study again with different participants. So the fact that we have such trouble in psychology agreeing on a proper measurement, like depression. How do I measure depression? I might give you a survey measuring depression. Someone else may give you an interview measure depression. Which is better, the survey or the interview? I don't know. I think it depends on who you ask. Or maybe we both use surveys, but we use different surveys. I use the Beck Depression Inventory, and you use the Patient Health Questionnaire. Two different measures of depression. Which one's better? They're both pretty good. Which one's better? It depends on who you ask. But because we can't agree on these things, and there's no sort of universal way to measure psychological constructs, that opens up for more measurement error. And if we have more measurement error, we're going to have smaller correlations. And that's the reason why in psychology, your correlations are not going to be as strong as they are in physics, biology, chemistry. And there's nothing wrong with that. I mean, psychology is complicated. I would say psychology is more complicated than physics, biology, chemistry. I mean, I love physics, but I don't really love physics. I mean, I love biology and chemistry. Physics I kind of find it boring. Um, but I love biology and chemistry. Those are wonderful subjects. But you have to admit that they're much easier to do research in terms of measure. They agree on the measurement. They may have differences in opinion in terms of their hypotheses and their theories, but at least when you're measuring something, most of them agree on it or come close to agreeing on it. In psychology, people don't agree on pretty much anything in terms of measurement, and that's why the correlations are lower. But you still find interesting relationships. People may disagree. That's fine. Let them run the study. Let them run your study. See if they replicate it. If not, let them run their own study. And that's what I mean by most correlations fall far short of perfect. They're going to be 0.5, 0.6. You'll be happy with that. Can correlations be trusted? If they're large enough, they can. So if your correlation is large enough, it generally is called statistically significant, which means that it does not occur by chance. Another way of saying that is in the population, the correlation is not zero. It's something other than zero. How do you get a statistically significant correlation? You get a larger correlation. So the larger your correlation, the more likely it's not due to chance. The more likely in the population the correlation exists. It's not just sample specific. In other words, it's not just due to your sample. You have a weird sample and you've got a value here that doesn't exist. If you looked at everybody, you would have no correlation, but because you had a weird sample, you get a correlation. So you don't get these lucky results. Statistically significant means it's real. It doesn't occur by chance. That means if you find something in your sample that's statistically significant, it actually occurs in the population at large. Remember that your sample is only a small subset of the population. So that's what we look for. And we generally use the 5% cutoff. So if our correlation or our result has less than a 5% chance of being lucky, right? That means that basically it's not in the population, it's only in your sample. If it's less than 5% chance of a lucky result, we say it's statistically significant. And we call this 5% the p-value. And if you take statistics, you'll learn much more about the p-value and why it has to be less than 5%. We use 5% as a cutoff because it balances out error rates, basically. It balances what's called the type 1 error and the type 2 error out. And I'm not going to talk too much about that because it's for a stats course. But basically, that 5% ensures that your result is not a lucky result, that it's a real result. If your correlation is close to zero, then you're probably not going to have statistical significance. If your correlation is close to 1, then you're probably going to have statistical significance. That's why larger correlations are better than smaller correlations. The most important reason why they're better is because they tend to be statistically significant, and the smaller correlations tend to be due to chance, or they're called error. More specifically, they're called sampling error. Basically, the difference between the taking a sample and the population value. It's sampling error. So I call it like luck, chance, and call it sampling error. They're all the same thing, basically. So you want your result to be statistically significant. The bigger the correlation, the more likely it's going to be statistically significant. It's not due to chance. What are the merits of the correlational method? Well, the biggest one is they have high external validity. That means you can generalize the findings because you're using a large sample. So whatever results you get in a large sample will probably hold true to the population. It's a lot different than case study. With a case study, you have one person. So how do you generalize from one person to a population? You don't. But it's much easier to generalize from a sample of, say, 100, 200, 500, etc., to a population. So it has high external validity, which means you can generalize the findings. You could also replicate studies. That means run the same study with different samples. So if someone's run the study before, copy exactly what they did, but just use different people in your sample. That's called replication. That's important. That determines who's right and who's wrong. If you can't replicate, then someone's wrong. Either the person that did the study originally is wrong, or you're wrong. Something is wrong with the way you did it. And in psychology, unfortunately, there's a problem with replication. A lot of studies cannot be copied. You can't get the same findings. And there's a variety of reasons for that. I think there's one of the reasons is the pressure to publish, that faculty members need to publish to get tenure and to get promoted. And there's, more pressure on them to get something out there, even if they know that or have trouble replicating it. They don't really care about it. They just want to get the results out there so they can publish it. That's a big factor. I also think that it's hard doing research in psychology, and it's hard measuring these constructs. And so if you're measuring with a lot of error, which we are in psychology, you're going to have problems replicating. Now, the other issue with the survey or correlational method is it lacks internal validity, which means you cannot draw cause and effect conclusions. But that's okay, because if I could find correlations and I could do regression, that's going to give me a lot of information, even if I can't say cause and effect, even if I can't say that traumatic experiences in childhood cause anxiety disorders. I could say they're related. They go together. That's not as strong as causality, but it's something. It's an interesting finding. And then I could drill down on that. I could do more research in that area. So just because you lack internal validity and you cannot draw cause and effect conclusions doesn't mean your research is worthless. It's important. It's a much better research design than, say, the case study. The case study is, in my opinion, unless you're using a very rare disorder, it's a waste of time. Unless you're trying to help one person without doing research, you don't want to publish it, you're just looking to help your client, then I guess you could do the informal case study. But if you're trying to publish research and figure out how the world works, or how anxiety or depression work in the everyday life, case study is not ideal. The survey method is better. Now, you may also say, well, the problems with the survey method are social desirability. Well, we can talk about that. That is a problem. So just continuing on the last slide, social desirability is when people, they respond in a way they think they should respond. It's called social desirability. And with surveys, there's always a possibility that they're not being as honest as you would like, that they're giving you answers that make themselves look good, put themselves in a desirable position or desirable light. You have to worry about that. Now, is that a problem with all surveys? No. Is that a problem with surveys on depression? It depends. It can be. People, if you put a question on your depression survey that says, have you ever thought about committing suicide or attempted suicide? People are going to be very unwilling to answer that honestly. So that's an important thing to keep in mind, is that if the more controversial or, I guess, troublesome topics you ask, the less likely you're going to get honest answers. So things I don't like to ask is about drug use, because people are not honest with drug use. You get all kinds of crazy things. I've never drank alcohol in my life. I never smoked pot in my life. Okay, sure. You're asking college students if they ever smoked pot, and they all say no. You're asking college students if they drink. They all say, I don't drink. I don't drink at all. And you know that's not realistic. I know this because I've given these kinds of surveys out to college students before, and you get all kinds of crazy answers. I once gave depression scales out to college students when I was working at Rutgers, and they all said that all 300 of them said I never thought about suicide before, and I just shook my head in disbelief that they never thought of suicide before. That's not true. College students think of suicide. They may think of suicide all the time. To say that none of them actually think of suicide at all is, that's not accurate. And I can understand why people are unwilling to admit that. Same with drug use. Even if it's anonymous, even if your name's not on it, you're not willing to admit it because it's a tricky topic, substance abuse. You don't feel good saying, yeah, I use drugs every day. People are not willing to say that, even when their name's not on it. They still feel bad indicating that, and so they don't. That's why you have to be careful of social desirability, and that's why when you're dealing with more sensitive topics, you have to be really careful how you phrase the question and how you're asking for things. And even something like sexual activity, you're going to get maybe not the truth in 100% of times. People are going to change things a bit. So the survey methodology is not perfect. There are social desirability issues. You also have issues where people don't really understand the question and they kind of try to guess the answer. That's a problem. You also have what's called a response set, where people will just answer the same, they'll pick the same option every time. So they pick if you ask them a question, strongly agree, strongly disagree, and then in the middle you have neutral. You'll see people just circle neutral for every question, like neutral, neutral, neutral. You go down the survey and it's all neutral. Or it's all strongly disagree, or it's all strongly agree. And you think to yourself, really? Are these people even reading the questions? Sometimes they're not. And you got to notice those patterns. You got to throw that data out. That's useless. You can't use that in your study. So you have these response sets where they're responding in the same pattern every time. You have social desirability. So those are downfalls of surveys. But what the good thing about surveys is you can get a lot of data and you can get it quickly. And most of the time people are honest and they're answering in a manner that indicates their true levels of whatever you're asking them to report on. It's not like everybody lies. But you will have people give social desirable answers. You have to be really careful how many of those people are in your sample. Now, moving on to other forms of correlational research. Within abnormal psychology, we have two special forms of correlational research. We have the epidemiological studies. This is looking at the incidence and prevalence of a disorder in the population. The incidence is the number of new cases in a given period. Usually it's a year. So how many new cases of schizophrenia are in the US in a year? That would be incidence. The prevalence would be how many total cases are in the US over the last year. So that's new cases plus pre-existing people. That's prevalence. And these are important because you can monitor how widespread the disorder is, how big of a problem it is in a particular community or population. You can also monitor, is it increasing? Is it on the decrease? When you're exposed to a traumatic situation, we know that the mental disorders are going to be on the increase. And we're going to see that in the next couple of years. We're seeing it right now, but depression, anxiety especially, people have been looking at new diagnoses the last 2 years, and there's a huge jump. Compared to last year, depression and anxiety are way higher. Longitudinal studies are a little bit different. So they're not looking at particular rates of the disorder, like right now, in terms of new cases and existing cases. They're looking at over time, over a period of a long time, is there a change in number of cases? And so they observe the same sample over sometimes decades of their life, and they monitor, is there a change over several decades of these people's lives in terms of mental illness? That's a difficult study to run because it requires maintaining contact with people and following up with them constantly to try to get accurate data over time. And people move and they stop answering your phone calls and they stop responding to your text messages and emails. And you got to track those people down and you got to kind of harass them a bit to stay in the study. I'm not saying totally harass them, but you got to be on their case sometimes. You have to follow up and be persistent to try to keep them in the study. You lose a lot of people with the longitudinal study. It's very difficult to keep people. The longer the study goes, the harder it is to keep people. I mean, I remember running longitudinal studies at BMCC over a period of 10 weeks, and I couldn't keep people in 10 weeks. So I had them come at the beginning, and then 10 weeks later, I had them do the post-test, and people were just disappearing. I couldn't keep the students coming to the study over a 10-week period. I lost half my sample. Now imagine if you're doing this for 10 years. I couldn't even do it for 10 weeks. It really is a lot of work and requires a lot of diligence and a lot of contact, following up with people constantly. Now, moving on to the second type of research design, the experimental method, or actually in this case, the third type of research design. We had case study and we had survey. Experimental method is when we manipulate a variable and then we measure an outcome. The manipulated variable is called the independent variable, and that is controlled by the experimenter. And the measured outcome is called the dependent variable. So by manipulating the independent variable, we expect to see a change in the dependent variable or the outcome measure. This allows us to draw cause and effect conclusions. And the reason why this allows us to draw cause and effect conclusions is we use this experimental method with random assignment. So random assignment is important because it balances out the two conditions or the multiple conditions in your study. So what does that mean? Let's say I'm testing a new drug. I want to make sure my two groups are equal when I'm testing out this new drug. I want them to be equal on anything that could affect their response to the drug, which could be gender. So I want those two groups to be equal with regards to gender because that could affect the drug, the effects of the drug. How about socioeconomic status, possibly, right? How about intelligence, maybe? How they deal with stress, etc. There's so many factors that could influence the outcome of an experiment. That I want these two groups. If I'm keeping it simple and I'm having two groups and I'm testing a new drug, I want those groups to be as similar as possible at the beginning of the study. And the best way to make sure those groups are as similar as possible is to use random assignment. So you randomly assign people to one of the two conditions. That makes the two groups equal. So I should have a relatively equal number of men and women in each group, a relatively equal number of smart people in each group, a relatively equal number of poor or rich people in each group, a relatively equal number of older and younger people in each group, etc. So I'm balancing out the two groups that I'm going to compare in my experiment by using random assignment. And I could do that by like flipping a coin. If I have two groups, I flip a coin. Heads, you go into group one. Tails, you go into group two. And I keep flipping until I get a large number of people in both groups. The more people, the better. You don't want to have like 5 people in each group because then the idea of randomly balancing out the groups is not going to work. You need to have a bunch of people. I would say, at least 100, 200 in a psychological experiment, probably more. It depends on how much money you have to spend on getting participants because you probably have to pay them. How many people are running the study? Do you have enough time? Do you have the lab space? There's a bunch of things you need to do to run an experiment. You need money, you need time, you need space. It's going to cost more money than, say, a survey. So you could be limited in how many participants you have because of those factors. But if I randomly assign to groups, I'm comfortable that the groups are even. So the only thing different now, since the groups are balanced out because of random assignment, the only thing different is the actual variable being manipulated, the independent variable. So that's why it's important for random assignment to be used. You also want the control group. The control group is the group that does not get the treatment. They get the placebo usually. The placebo is the sugar pill. So if I'm randomly assigning to 2 groups, one group should get the placebo, that's the control group. The other group should get the actual treatment, the real drug, which is the experimental group. If I have 2 groups, I have one control group, one experimental group. Control group gets nothing. They get the placebo is basically nothing. It's a sugar pill. It looks like the real drug, might taste like the real drug, but it does nothing for you. You think you're getting the real drug, but you're really getting nothing. That's the key of the control group. You think you're getting the treatment, but you're not. And the other group, the experimental group, actually gets the treatment, whatever that treatment is, whether it's a new drug, whether it's a new therapy, etc. And then we compare. Is there a difference between the control group and the experimental group? And we look at statistics to see if there's a difference on the dependent variable. We compare them on the dependent variable, which, if I'm studying depression, it's depression. If I'm studying anxiety, it's anxiety. If I'm studying PTSD, it's symptoms of PTSD, etc. Depends on what you're studying. That's your dependent variable, your outcome. And we had mentioned random assignment. So you flip the coin and assign them to 2 groups. Half the people go to the control group, half the people go to the experimental group, and then you hope that there's a difference. You hope that the experimental group is different from the control group, but by using random assignment, you are guaranteeing that those groups are equal with regard to everything except for the independent variable that's being manipulated by the experiment. So in this case, if I'm doing a drug study, it's the drug. So your 2 groups are equal with regard to any variable, any factor in the study, except for the actual drug or placebo given, the treatment. And that's very important. That rules out any of these other factors playing a role. The difference must be caused by the treatment, which is the drug compared to the placebo. You also want to run the experiment as blind, which means that the researcher does not know what group you're in. So the researcher that's giving you the pill doesn't know whether they're giving you the placebo or the real drug. They have no idea. Half the people are getting the placebo, half the people are getting the real drug. The person giving the drug has no idea what they're giving. So they're blind. The participant doesn't know what they're getting. The participant's either getting the real drug or the placebo. They have no idea, so they're also blind. So when you have 2 blinds, it's called double blind. It's a double blind study. That's when the researcher doesn't know what they're giving and the participant doesn't know what they're getting. So they're both blind. That's the best study to run. Double blind, placebo-controlled study. So you have the placebo, you have the real drug, and you have both the participant blind and the researcher blind as to what they're getting or giving. That's key. That makes the study unbiased. So that's the best type of study you can run, the double-blind, placebo-controlled experimental study. You can't always do that, though. Remember, with the double-blind, placebo-controlled experimental study, you need to have random assignment. You can't always randomly assign people to groups. It's easy if you're going to test a drug. You randomly assign to placebo or the real drug. That's a very easy situation. But what if you're doing something more complicated, like you're testing whether people with post-traumatic stress disorder differ from people that are normal controls? They don't have post-PTSD, and you want to see how they differ with regard to how well they perform in school. So you want to compare PTSD to people without PTSD and see what their grades are like. Let's say you're doing that study. Well, can you do random assignment there? Can I say you're going to be in the PTSD group and you're going to be in the control group? No, you can't do that. You can't assign people to the PTSD group. You can't just say you're going to get post-traumatic stress disorder. It doesn't work that way. And you certainly can't terrorize them to the point where they're going to get PTSD. You can't just say we're going to put you in an impossible situation and we're going to make sure that you fall apart and that you end up traumatized. That's something like you saw in the Stanford prison experiment, if you're familiar with that. The Zimbardo train wreck of a study that he ran in the 1970s, where half the people were assigned to be prisoners and half the people were assigned to be guards, and the guards ended up abusing the prisoners. And the prisoners were actually traumatized to the point where Zimbardo eventually had to stop the study, even though he didn't want to. He was convinced to stop the study by his girlfriend at that point. And the people in the study that were the prisoners were really shaken up. These are college kids. And they were in the basement of a lab, basement of a building where the lab was at Stanford University. So in that case, Zimbardo actually inflicted trauma on people. You can't do that today. So that you can't, set up a situation where you're going to inflict trauma. You're in the trauma group. You can't just inflict trauma on people. It doesn't work that way. In the 1970s, it worked because there was less control over experimentation. You've seen that with the Stanford prison experiment. You've also seen the lack of control over the experiment when it comes to, the Milgram study, which is another awful study. They're famous studies in psychology, but they're just awful studies in terms of ethics. Things that you could never do today. You could never do the Stanford prison experiment right now. You can't induce trauma to people. So if you want to study the effects of trauma and you want to compare people experiencing trauma to people not experiencing trauma, you can't randomly assign. You can't randomly assign people to get trauma. You have to use the people that already have been traumatized by something else in their past. So you're using people that already have trauma. You're using preformed groups. Have you been traumatized? What traumatized you? First it says, I was assaulted. That's trauma. They go in the trauma group. You can't assign people to get assaulted. You have to use ones that already have been assaulted for some other reason. And so when you're doing these kinds of studies and you can't randomly assign, they're called quasi-experimental designs. This is basically doing a study without a random assignment. Can you draw cause and effect conclusions? If you don't use random assignment, the answer is no. If I cannot randomly assign because of the situations that I just talked about, you cannot draw cause and effect conclusions. And so you can't really run a true experiment. You end up running this quasi-experiment. It becomes almost like a correlation. It's almost like a survey research because you're not going to be able to draw cause and effect conclusions. And then there's some other similar designs that are problematic as well. But quasi experiment is a very popular design that people run when they can't randomly assign. So whether it's a child with a history of, child abuse or some other trauma or people that have had some negative experiences in life, can't randomly assign that stuff. Now you can match them. So you can find two people that both have had trauma and you can assign them to two different groups, but matching is not ideal. And you can't really match them if you're looking at comparing child abuse to no child abuse. You can't match them there. You can match them with regard to age, I guess. You could find one person. If one person that's been abused is like 30, you could match them up with another person that's 30 years of age that has not been abused. Or you can match them on IQ scores or on how much money they have or how educated they are. You can match them, but it's not the same as random assignment. Matching is tricky. It doesn't have the same impact because they're not randomly assigned. They're matched. Two 30-year-olds, one's abused, one's not. They're matched up on the fact that they're both 30 years old. You're only matching them on one variable. When you randomly assign, you're getting rid of any kind of difference, no matter what it is. Things you know about, things you don't know about. When you're doing matched groups, you're only eliminating the things you know about and you can match on, which is usually one or two variables. That's not the same as random assignment. So matching is not that effective. And personally, I never use matching. If I can't run a regular experiment with random assignment, then I don't run it. I run a survey. I don't try to match people up. It's just, I don't think it's very effective. Now, in a natural experiment, it's the same thing as a quasi-experimental design, except that the groups are not caused by some kind of historical event. They're caused by something occurring in nature. So this is not like, trauma, abuse versus not abuse. This is something that's caused by nature that leads to a difference, like an earthquake or flooding. So a lot of studies have been done with people experiencing huge earthquakes. So you compare people that experienced a huge earthquake to people that never experienced a huge earthquake or never experienced an earthquake at all. And you can compare those two groups. What's the impact of having, being through a huge earthquake or huge flooding or tsunami or tornadoes or whatever? What's the impact? You can do that. That's called a natural experiment because the groups are formed by some event that occurs in nature. And a lot of this is like trauma-related research because people that have been through, severe earthquakes or other diseases or difficult living conditions, they have a lot of trauma in their lives. You also have analog experiments where you can try to test your study on, say, animals. So if I want to see how stress leads to depression, and I don't want to stress out people because it might be unethical to stress human subjects out to the point where they're depressed, I could then stress an animal out. And you see a lot of these studies where they put the mice in a cage and then they electrify half the cage. And so if the rat goes to half the cage, they get a electrocution, they get a shock. And you can repeatedly shock these animals and see how do they work under repeated shocks. And by running these kind of analog experiments, we found out that by repeatedly shocking the mice, what happens is they stop doing everything. They just sit there and take the shock. And they don't even try to escape it. They just deal with it. And they kind of give up. They just sit there and just repeatedly shocked. And that's very similar to how humans work. When you're very depressed, you just kind of give up. You just start doing nothing. And so sometimes you can draw the conclusion between animals and humans by testing on animals. However, if you're doing psychological studies, animals aren't necessarily the equivalent of humans in terms of cognition and behavior. So we're very similar with regard to, say, like anxiety, um, pain regulation. We're very similar to animals. But when it comes to more complex things like, say, pride, uh, you can't really compare them. You can't really compare pride in a mouse compared to pride or disgust. Say disgust too. Disgust in a mouse compared to disgust in a human. What does disgust in a mouse even look like? What does pride in a mouse look like? I have no idea. These are not emotions that animals show. Animals show anxiety. Animals show aggression. You may even say animals can sometimes show depression, but they don't show other complex emotions like pride and disgust. So there's a lot of things you can't study in animals because there's no equivalent in animal compared to a human, and plus you're using mice. You might say monkeys would be better, but monkeys cost a fortune, and you're not going to have access to them. You're not going to be able to pay for them, and they're difficult to handle. You have to be really trained to handle them. Whereas mice are dirt cheap and they're easy to handle because you just put them in a cage and that's it. I've worked with mice before. I haven't worked with monkeys, but I've worked with mice before. And, as upset as the mice are, they're very easy to handle. You know, they're not going to run around and try to escape and do all kinds of things to you like a monkey will. And they're also extremely, extremely cheap. And the monkeys are very, very expensive. Now, another alternative design, which is used today in human beings, is called the single subject experiment, where you measure before and after. And you see this working with autistic people with autism. Uh, you'll hear about applied behavioral analysis. Well, applied behavioral analysis is the equivalent of this single subject experiment. So what you do is you take a baseline. So you want to change a behavior. So you take a baseline of the behavior. Let's say you're trying to change sleep. You take a baseline of sleep, and then you have to introduce some kind of intervention. How are you going to increase sleep? So with the ABAB reversal design, measuring sleep is the baseline, which is A, the first A, your baseline. How many hours of sleep do you sleep, per night do you get? That's your A. Now B is your intervention. So the intervention can be, we're going to have you do meditation every night before bed. 15 minutes of meditation every single night before bed. So that's my intervention. And then I'm going to measure, does the intervention work? So am I getting more sleep? So after I do the intervention, I give 15 minutes of meditation, and I now measure sleep again. Do I have an increase in sleep? And if I do, that's good. That's what I want. Now what you have to do is you have to remove the independent variable. So now I have to say, okay, I have an increase in sleep. I'm going to stop doing the intervention. I'm going to stop doing the meditation. And I want to see if I go back to baseline. So without the meditation, am I going back to where I was at the beginning? And if I do that, now I have to reintroduce the intervention again. So B again. So now more meditation. Am I increasing my sleep again? Second time. So it's almost like you're making it work twice. You want to see if it works the first time, then you're going to withdraw the treatment, then you're going to introduce it again. And this is done in one person. So this is like a case study, except that we're actually doing some kind of manipulation here. Obviously, this is not a random assignment because it's only one person. But I am manipulating, I am giving the intervention and removing it. So this is a much stronger design than the case study because the case study is not doing anything. It's not manipulating anything. It's just basically relying on what someone's telling you. Here, you're actually doing some kind of manipulation. You're doing an intervention to see if the intervention works. Unfortunately, it's only on one person, which is a problem. But it's a much stronger design than the case study because you are introducing the reward or you're introducing the intervention, you're removing the intervention. And this is kind of how it's graphed. You have a baseline, you have the intervention, which in this case is positive attention. So you're like praising somebody for studying. They're measuring basically how much time you spent studying. So normally it's pretty low. Now, if I give positive attention and praise, the child's studying habits go up. Now, if I take that positive attention and praise away, guess what happens? The child study goes down. Now, it doesn't go down to baseline. There's still some gain there, but it does go down from the intervention. So you're still seeing gain even after withdrawing the intervention. You're still seeing a positive change here. There's still an increase. But the increase is much greater when I give the intervention again. I start paying attention to the children. Their studying time goes up again. So then I know, since I introduced it, I withdrew it, I introduced it again, that's pretty strong evidence that it's working. It is one person. You gotta keep that in mind. But in this one person, it's working, and you can gather other people if you want. You can get a whole bunch of people and average out the results. And that would look pretty interesting. And it wouldn't be basically overgeneralization because you're averaging out the results. So these single subject experiments are very similar to case studies, but they're improved because you can actually draw cause and effect conclusions to a degree here. Because you're introducing a manipulation, and then you're removing it, and then you're reintroducing it again. And that shows you whether or not this intervention is causing a change in the behavior. So although it has low external validity, because it's based on one subject, it has higher internal validity than a case study because I'm actually manipulating a variable. I'm introducing it and removing it, and I'm looking for a change. And you would think that change is directly related to whatever variable was introduced or removed. So it's a step up from the case study overall. Now, the last thing I want to talk about is how do I go about actually even running the study? And that involves getting the institutional review board involved in reviewing the study and approving it. This is a committee at the university, most likely, that basically looks at your protocol, what you're going to do, what kind of study you're going to run, and they determine whether it's ethical or not, and it's safe. So the goal of the institutional review board is to minimize risk, to minimize harm to participants, to make sure what you're doing is not going to hurt them or harm them in any way or discriminate against them, right? And possibly, it protects you from a lawsuit as a researcher. It protects the university from being sued as well. Anything that is like really controversial would need to be thoroughly vetted by the Institutional Review Board or the IRB, and it probably won't be approved. So like Stanford Prison Experiment would never get approved today. Never. The Milgram study never get approved today. Because there's a lot of unethical components there, and the IRB is going to reject that. But you must have IRB approval before you start the study. And in most cases, it's like just a bureaucratic hoop to jump through. It's not my favorite thing in the world to submit the IRB proposal and to have it reviewed before I start my research. I want to make sure that they say it's okay. And I have to give them a description of what I'm doing. And then I have to wait. And it may take a week, it may take 2 weeks, it may take longer for them to get back to me. And I hope they approve it, but usually what happens is they get back to you and they say, okay, we want you to change all these things and resubmit it. So then you have to go back and change what they asked you to change and resubmit it, and then they'll usually approve it once you've agreed with that, what they think. But you must have, the IRB, the Institutional Review Board, must review your research before you can conduct research. Always must review it. And if they agree with, if they agree that it's good research and it's not going to hurt anybody, and the key here is like, what are the benefits and what are the drawbacks of the research? Do the benefits outweigh the risks? So basically, the rewards outweigh the risks. That's what they're looking for. If there's a lot of rewards, if the study is really interesting on something that hasn't been done before, and it can make a big impact, they're more willing to deal with a little bit of risk. But the key here is keep it at minimum. Make sure risk is minimum and make sure you address it. If your risk is above minimum, then you're going to have a problem. Then you may be called in to present your case for the entire IRB review board, which could be like 20 or 30 people. You don't want that situation. You don't want to get to the point where you have to present your research to like 30 people that are basically looking for reasons to reject it. And that's if you have a lot of unethical things in your study. Like if you're going to physically or mentally hurt someone as part of your research, it's not going to be approved. So it's very important that you get approval from the institutional review board and that you're able to carry out the research and, in an ethical manner. And you cannot start any research until the IRB institutional review board gives you permission. So that's always the first step. Before you do any research, you must draft the IRB and submit it and get it approved. That's before you run any particular subject. You cannot run any person in your study before this is approved. And the IRB wants to make sure that participants enlist voluntarily, that they get informed consent. Informed consent is at the beginning of the IRB submission. And what that basically is a description of the study. So what are they going to be required to do? And how's it going to happen? And they have to basically sign off on it. So your participants have to sign this informed consent form, saying they approve it, they agree to it, to the study. So you cannot run a particular person, subject, participant, without getting IRB approval and without having them sign the informed consent. Cannot do it. The participants also have to be allowed to leave at any time. That's another issue that you may not like. People will just get up and leave. And in most cases, if you're paying, you'll have to pay them, and they'll still leave. If they have a legitimate reason to leave, you have to pay them. Like if they feel uncomfortable with the questions you're asking, they can just get up, leave, and they get a paycheck. If you agreed to pay them for their time, you have to pay them, which is frustrating because it does happen. People will just get up and leave and expect to get paid. And then you could fight with them on it, but good luck with that. A lot of times the universities will side with the participants in a lawsuit. So, as I mentioned before, the benefits of the study outweigh the risks of the study. The participants must be protected and prevented from receiving physical or psychological harm as much as possible. They must have access to information about the study that would be in the informed consent form. And the participants' privacy is protected from confidentiality and anonymity. So your name will not be disclosed in the research if you're asked to put your name down. You may not even be asked for your name. If you're not asked for your name, it's called anonymous. And no one can trace your answers at all. If they ask for your name, usually it's because the surveys or the data has to be matched up, like pre and post. And you need to match it up with like a name or some other identifiable character. But that's basically what you would ask. So it's a pretty straightforward process, getting approval and recruiting participants, but you can reach some bumps in the road, and you may have to make several revisions before your study is approved for everybody to run. So that's it for Chapter 2. Hope you enjoyed. Hope that clarifies some things, and I'll see you next time.